Hi, my name is Mrs. Abbott and I teach kindergarten, and one of my favorite math manipulatives to use are Unifix cubes. One way that I really like to use them at the beginning of the year is practicing one-to-one correspondence counting. 1, 2, 3, 4, 5. I also really like to use them with a tens frame, just counting out again. 1, 2, 3, 4. Also like to do it with a couple more colors, maybe when we're making 10. And now I have 4 and 6 makes 10. These come great and handy when you are adding and subtracting. So maybe I have 3 plus 3 gives me 6. Or for subtraction, 5 minus 1 equals 4. Another thing that we can do with these, in kindergarten we do measurement in non-standard units. So we are going to measure how tall, long, or short something is with cubes, and these are great because they can stack together. If you don't have Unifix cubes like this at home, you can use anything for counters, buttons, miniature erasers, whatever you can find to help do some of these same things. And now look, now my book is 1, 2, 3, 4, 5, 6, 7 cubes long.
First grade, Unit 6, we learn about two-dimensional shapes. First, we study the attributes of two-dimensional shapes. Can you sort these by their attributes?
Defining or non-defining attributes.
Non-defining color and size. Great job. Can you sort them by their defining attributes? Their number of sides and vertices. Fabulous. Then we talk about composing two-dimensional shapes to make new shapes. Can you use 3 triangles to make a trapezoid? And can you use 2 trapezoids to make a hexagon? And can you use a trapezoid and a triangle to make a bigger triangle? Awesome. Can you compose your own new shape with these shapes? Great work.
Hi, I'm Mrs. Doran, a second grade teacher, and this is Mrs. Lane, an intervention specialist, and we're going to talk to you about base 10 blocks. So this is a tool that we use quite a bit in math with second grade, and these are 10 rods. They represent 10, and these are ones, and 10 of these would equal a tens rod. So we use these so that kids have a visual understanding of math and they can apply this strategy to a more abstract concept to give them a visual, and it also allows for collaboration between students.
All right, so we're going to show you an example of how this works. So if this is your math problem, we have 78 minus 25. We tell the students when you subtract, you only build the top number because we're taking away. So I have 7 10 rods here to represent our 7 tens. Then I have 8 ones to represent our 8 ones. So then we come over here and we say, okay, we need to take away 25. So we teach the students to always start in the ones place. So I'm going to take away 5. So I would go 1, 2, 3, 4, 5, and then I see that I have 3 left. So then I'm going to write a 3 down here. And then I come back and I need 7 tens, and I'm going to take away 2 tens. So I'm going to take away 1, 2, and then I have 1, 2, 3, 4, 5 left. So then my answer would be 53. Now, I'm going to show you another example because I feel like this is where it can get a little bit tricky with our kiddos. So I'm going to change this. So instead of 78, I'm going to make this number a little smaller, and I'm going to make it a 3. So if we have 73, take away 25, again, we start in the ones place. I can't take away 5. So what we teach the kids is we're going to take 110. I'm going to kind of show you with a marker too. Just like Mrs. Doran said, this is worth 10 ones, and we teach the students this. So we take 110 and we break it into ones. So I'm going to put 10 ones up here, and I make it separate from the 3 that I already have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm gonna move this one. Okay, and then we teach them to X that out, but I'm not gonna write on her things. So we have 10 here and 3 here. So that means that we technically have 13 ones, which is kind of where we were all taught. We just cross off our 3, make this a 13, and now we only have 6 10s, and we can take that away. So now I can go back, okay, 13, take away 5. I can do that now. So 1, 2, 3, 4, 5, and then we have 5 and 3, so that would be 8. And then now I have 6 10s, and I'm going to take away 2, 1, 2, and now I have 4 left, so our answer is 48. So, and this works very similarly with addition. You would just build both numbers though, because you're adding them together. So, hopefully this helps you guys at home. When the kids start talking about these, you know what they are.
All right, we use these tiles when we are learning multiplication on how to build arrays. And then we can also use these when we are doing area to link area to multiplication. So one of the ways that I have used them to help problem solving with area is giving them the square units of the area. So for example, the rug in the room was 18 square units. They would have to build the rug, and then they would have to know what 2 numbers would equal 18 when they are finished building their rug. So then they could manipulate the tiles to see how they can make a rug that makes a square or a rectangle. And then if they get one and it doesn't make a square or rectangle, then they know that this can't be the area for that. So then they can manipulate it more to get to where they can make a rug that shows an array. And then I can ask them, okay, so what is the length and width of your rug? And then they could show me that it's 2 times 9, which would be 18 square units for this rug. And then I can easily just add 3 more. Now they had 18, now they have 21. So now they have to do something else to find the area of that rug. So a lot of times when they're problem solving, finding area, they can find the answer if they know the length times width. But if they're told what the area is and they have to figure out what the length times width is, that's where we have trouble. So using the manipulatives helps them being able to figure that answer out.